Welcome to CW 4.2. Today we're going to finish up our study of limits, and what we're going to do is talk about a method called the brute force method. So right here, because it says find the following limits using the brute force method or sketch a graph. So let me explain what that means. When we say brute force method, that basically means we're relying on our number sense and logic to figure out what should happen. So up here, I'm going to put BFM facts. So brute force method facts. So C is going to be our constant, and we're going to put a small number like 0.0001. You can pick any constant like 10, 5, 1. If you imagine a constant over 0.0001, think about what happens. And if you're not sure, we can grab a calculator. So imagine my calculator here. Let's say I do 5 over 0.0001. Notice the number gets huge, becomes 50,000. Now if I do 5 over 0.000001, it keeps getting bigger. So I bring that up because over here, if you have some constant over some tiny number, what's happening is that it's actually trending towards infinity, like it's getting really, really big. And that's your first brute force method fact. So if I do some constant over negative 0.0001, that is going to trend towards negative infinity. Now we're going to flip it. So I'll draw a line here. Let's say we have some constant over infinity. Think about where that would trend. So if you're not sure, let's grab our calculator. Let's say we have 5 and divide it by a really big number like that. Notice how now it's 0.000005, and if we kept going, think about what it's approaching. That's a really tiny number, and what it's doing is that it's approaching 0. Now, will it matter if it's a negative infinity? Like, will that matter if I go back here and I change this to a negative on the bottom? Well, it does make the outcome negative, but look at what you're approaching. You're still approaching 0. So over here, we can even be more specific. We can write, it doesn't matter if it's positive or negative, it'll trend towards 0. And the last fact is if you have infinity over a constant, what should happen? Well, that should be common sense, hopefully. Let's say we have some constant like 5. If you have a million over 5, like this, some giant number over 5, it's still really, really big. And if I make this number massive, it's just getting even bigger, which means all you're going to do is approach infinity. Now, that might seem weird, like why are we talking about that? You're going to see that in our limit problems here. Because all of these, right, it's all about this keyword approach. Everything is about approach. So for this one, it says the limit as x approaches 0 from the left of 1 over x. So what you want to do is think about the number 0 from the left, right there. That would be negative 0.0001, right? That'd be a number really close on the left. We're going to plug that in. So we're going to write 1 over negative 0.0001. Well, didn't we just talk about this? A constant, 1, over a tiny negative number, super tiny right here, that should approach negative infinity. And look, we did it. We did the limit without really doing anything. We just really thought about what should happen. And if that didn't really make sense, you can think about the graph. We know the graph should look like this. And I can verify approaching 0 from the left right there, that's definitely approaching negative infinity. Now for B, right here, notice how it's approaching 0. It doesn't specify a side, right? So in order to do the brute force method, we actually have to plug in 2 numbers. And we could do that, but if you have that situation here, For this one, it's going to be better to graph. So I'm going to write graph this. So up here for our brute force method, we're going to add a little note. This is ideal for one-sided limits. If it's not one-sided, the brute force method isn't that great. It'll still work, but it's just not great. Because if I graph this, all of you should know that 1 over x squared is our volcano graph, right there. I can see right here what we're approaching at 0. It's approaching infinity. Let's go to our next one. Approaching 2 from the left. So once again, you can imagine your number line. Here's 2. Let's approach it from the left. That'd be like 1.999. We're going to plug that in. 1 over 1.999 minus 2. That's 1 over negative 0.001. And that's going to approach negative infinity. And there's our limit. A couple more here. So now we're approaching negative infinity. So you actually can do a brute force here, because infinity is technically one-sided. So I'll write a big note. Infinity is one-sided. Because if we're saying approach negative infinity, that means approach basically from the right, or you're going to the left forever. So we actually could do the brute force method here. We could do 2 to the negative infinity, which would then be 1 over 2 to the infinity. And now notice how we're in a situation where we're a constant 1 over a giant number, and that's going to approach 0. So the brute force method's still valid here. Now, of course, we could graph, right? This is, if you have a basic function like this, we could just graph it, because this is a graph you studied in Algebra 2. The exponential graph just looks like this. And I can see, approaching negative infinity right here, we're definitely approaching 0. Okay, we got a couple more. So 4 plus, so definitely a brute force method here. There's 4. We're going to approach it from the right. So that's 4.001. Let's plug it in. So that would be 1 over 4 minus 4.001. That's 1 over negative 0.001, which is once again negative infinity. Now we go to the last example here. For this one, let's just plug in infinity. 100 over infinity. And look, that's 0. So those are pretty cool. And again, we're practicing the brute force method, or you could graph this. So this one we actually could have graphed as well, because that's a graph we should know. 100 over x, that's basically the 1 over x graph stretched, but it'll just look something like that. And again, I can see right here, that's definitely approaching 0. Okay, here's the last part. Limits at infinity of a rational function. So notice how we're going to infinity for all of these. That's going to be an important fact. And it's actually going to be building off of the brute force method. There are a couple of things we're going to do. We're actually going to we're going to start with the summary, because I'm going to give you the rules. So for limits to infinity, there's a couple of things we like to do. The first thing we're going to do is put the numerator and denominator in quote order. So think of that as standard form. Essentially, it's like saying you want the greatest exponent first, and then it should go down from there. The second step is going to be we cross out after the leading term. And the third step is going to be reduce and plug in infinity. So those are the steps we're going to do. And of course, out of context, that doesn't really make sense. So I'm going to explain it as we go. So for number 1, the first thing I'm going to do is rewrite it. So think of it as like standard form. So the top is good, so we'll leave that alone. The bottom is negative 5x to the 4th minus 4x squared plus 3. Now the interesting thing is, because we're going to infinity, imagine to plug in infinity for all the x's. The 9 and the 3, they're actually insignificant, because if you just add 9 and 3 to like infinity squared, it doesn't really matter. It's a super small number. And same thing for this. Infinity to the 4th power is going to be so much larger than infinity squared that these are actually insignificant. So when you're going to infinity, I can really highlight that, there are some special rules we can do. We can actually eliminate all of that, which means the problem really simplifies down to here. The limit as x approaches infinity of 2x to the 4th over negative 5x to the 4th. Once we've done that, we can do algebra. Let's cross out those. And look at what we're left with, negative 2 over 5. That's the limit. Let's do the same thing here. So for the second one, it's already in order, which is great. So let's cross everything out after that. Let's rewrite it. 5x to the 4th over x to the 5th. We're going to reduce it using algebra. Now we have limit as x approaches infinity over 5, or for 5 over x. Now we're going to plug in infinity. And now it's a brute force method. You have a constant over infinity. That's going to go to 0. Now for the final one, let's write it in order first. So the top should look like that. The bottom right here. We're going to cross out after the leading term. And we have our expression. Let's reduce it. So now we have the limit as x approaches infinity of x. So plug in infinity. The limit is infinity. And that's it for limits to infinity. Now remember, these steps we're doing, we're crossing out everything after the leading term, all of this stuff right here. We're only doing that because we're going to infinity. If you're going to a regular number, like the ones up here, going to 4, going to 2, going to 0, you would not do that. You only do these special steps when you're going to infinity.